According to the Identity Theft Resource Center, in 2013 there were 614 data breaches. Of those, 55 were higher education institutions. These institutions accounted for 9% of the total breaches, with over 3.2 million records being exposed. As of July 1, 2014, there were 25 higher education breaches reported, which accounted for 6.6% of the total breaches and over 1.1 million records being exposed. Hacking continues to secure the #1 spot for the method or type of breach, representing more than 1/4 of the total recorded data breaches for 2013. Data on the move, or data transferring from one system to another, accounted for 13% of the total records being exposed. So, what can you do to avoid being breached? Educate yourself and your organization. There is not one simple step that is the best solution for keeping your students' payment data secure. It is really a three-part solution involving EMV, end-to-end encryption, and tokenization. No doubt that the biggest buzz in higher education is regarding the use of EMV. What is this new technology and what does it mean to your institution? EMV, for Europay, MasterCard, and Visa, or chip cards, helps fight fraud at the physical point of sale by verifying that the presented card is genuine. The smart card chip contains dynamic data that is validated in a more secure manner than the static data of a magnetic stripe. The data is always changing, which makes the card data harder to counterfeit. The intent is to make debit and credit cards safer by storing personal information on computer chips rather than magnetic stripes. Visa and MasterCard have announced schedules for shifting fraud liability to merchants who do not incorporate EMV capabilities. Should you implement EMV? The decision is really up to your organization. As per the card brands, it is not mandatory for merchants accepting payments to implement EMV. However, since the card brands will be shifting liability back to the merchants not using EMV, you must consider if your institution is willing to accept the amount of chargeback losses that can be attributed to fraud, and estimate what those levels of card fraud will be after the liability begins to shift. Another consideration is student perception. What will your students and their parents think of your institution for not accepting chip cards if major and mid-sized merchants accept them? Concern for security has been stated in many recent studies. These studies show that consumers are aware of the risks and will most likely respect organizations that are like-minded. For those institutions with point-of-purchase terminals, you will also need to consider the following. Are my current terminals or customer-facing payment devices EMV co-listed? It is paramount that you reference this site to verify that the terminal you either have or will be purchasing is on that list. Can I retrofit my current terminals to add a customer-facing PIN pad that provides EMV contact and contactless acceptance, or do I need to invest in new terminals? Your payment processors or acquirers can tell you your options. What is the hardware configuration that best fits my institution? For example, if students pay at the counter at the bookstore, you may not need to consider portable acceptance. However, if students are paying at an athletic event or other institution event, you may need to have portable devices, such as mobile, available for payment acceptance. Do I need both contact and contactless? In some quick services areas, such as the campus restaurant, it makes sense to use contactless acceptance. Remember, to qualify for liability shift protection, the card brands mandate implementation of both contact EMV and contactless EMV. After determining that you will move forward with EMV implementation, you'll need a plan. Institutions should take a holistic approach to EMV acceptance, and that includes a commitment from the top down and throughout the organization. As part of your planning, we suggest that you include your payment processors, POS providers, and gateway providers. This planning will be instrumental in your approach to updating your payment acceptance systems, as well as acceptance solutions including terminal applications, virtual terminals, and others. The internal rollout of EMV will require time and patience from both your staff and your students. No doubt these changes may be frustrating. However, with the proper training and education, you will eliminate many of these issues. Most notably, you will experience getting over the swipe. We are all accustomed to swiping our card. With one movement through the terminal, the magnetic stripe is red. But with EMV, the card must be kept in the reader. Hold time for contactless transaction completion. Consumers will need to get used to the process of waving their card and how fast or slow the card wave should be. forgetting inserted cards in readers, not knowing what to do if the customer locks their card, staff recognition of a chip card, contact or contactless. When implementing EMV-capable hardware, you should retain the ability for non-EMV cards to be swiped, manually entered, or tapped. For example, the Ingenico model ICT250 allows you to retain current card functionality while still allowing for EMV chip cards usage. A major step in safeguarding your data is deploying end-to-end encryption. What is end-to-end encryption? With this encryption model, a card's data is virtually never in a readable form. From the moment the terminal reads the card through authorization, card data is always protected and never in a form that can be read outside of the processing system. But the important point here is encryption from end to end. When the data becomes decrypted at any point in the process, it is vulnerable to theft. Unfortunately, the sensitive data must be decrypted and re-encrypted with different keys along the entire path. This process must take place in a hardware security module, much as PINs are processed at ATMs. Let's explain this further. In a typical card-present transaction with standard point-to-point encryption, the customer swipes their card through a standard terminal or wedge device. The card data transmits from the terminal or wedge to the authorization network gateway. From the authorization network gateway, it transmits to the processor or acquirer for authorization. The processor or acquirer then transmits to the data store. While data is encrypted between each of these zones, data stored in each zone is unencrypted and re-encrypted, therefore vulnerable to breach. In a typical card-present transaction with end-to-end encryption, the same steps take place. However, with end-to-end encryption, data is protected by encryption while stored in every zone, in addition to being encrypted in transit between zones. Tokenization should be required to protect the historical card data once a transaction is authorized. What is tokenization? Simply stated, it puts substitute information or a token in place of the real card and transaction information stored. So if the system is compromised and tokens are taken, they have no real value in the outside world. A token is a unique value that cannot be mathematically reversed or decrypted to expose the sensitive data, such as a primary account number. Tokens, specifically multi-use tokens, can be generated in various formats. Two popular token formats include non-format preserving and format preserving. Non-format preserving tokens consist of 20 to 32 numeric or alphanumeric characters. Excluding digits 7 and 8, the token value is completely random. Digits 7 and 8 are reserved for the Enterprise Tokenization Service database ID. A format-preserving token is one that matches the formatting characteristics of the original sensitive data. This is done on a character-by-character basis, so that the tokenized or encrypted data fits in existing fields, eliminating the need for database schema changes. For example, a 16-digit credit card number can be tokenized or encrypted with the output guaranteed to also have 16 digits. Heartland's tokenization process supports credit card numbers ranging from 13 to 19 digits. The relationship between tokens and sensitive data resides in a highly secured token vault. The token vault centralizes the security of and access to the sensitive data. The token vault may also be referred to as a card data vault for implementations where tokenized data is limited to card data, such as primary account numbers. Heartland's tokenization service supports both single-use and multi-use tokenization in both a non-format preserving and format preserving structure. It is our belief and experience that EMV, end-to-end encryption, and tokenization are not mutually exclusive technologies, but rather the 1-2-3 punch that protects payments and knocks out card fraud. EMV eliminates acceptance of cloned or counterfeit cards. End-to-end encryption protects cardholder information within the terminal or phone, as well as throughout its life cycle. Tokenization eliminates storage of cardholder data for recurring, billing, reservations, card on file, or other uses. To learn more about how you can protect your institution when it comes to credit and debit card payments, contact us at 1-866-841-3274 or visit our payment pages at www.heartlandecsi.com.